Hello, I'm Bobby, and today I'll teach you about a question number 5 from AP Chemistry exam 2017. First of all, introduce the topic. My question is about thermodynamics, which is a branch of science concerned with heat and temperature and their relation to energy and work. So, look at this question. First of all, the first part of the question A, calculate the magnitude of the heat energy in kilogram absorbed by water. So this one is pretty simple. So here's my solution. First of all, you introduce the equation, which is Q equals mc delta T, and then you can just plug in the value. And here is the mass is of the water, so it's 125 gram. And then we have to apply the specific heat of water, which is 4.18, and then the temperature change, which is from 22 to 51.1, so we just subtract that, and after that we put in the calculator. Is about is 15200 joules, but it wants the answer in kilojoules, then we convert it into kilojoules. Okay, the second question, based on experimental data, if 1 mole of that is combusted, how much heat in a kilojoule is released? You report your answer with the correct number of significant figures. So there's two things they have to do in this one. First, we have to find the energy of 1 mole of that, and also we have to convert it to the correct significant figures. So what we do first, we find the molar mass of this compound, which is 60.09 gram per mole, and then we know 0.55 gram of this is combusted, and it released 15.2 kilojoule energy. So we can find it through the ratio. So we can first find what's the mass of 1 mole of that. So we can do 60.09 gram per mole multiplied by 1 mole of that, which is 60.09 gram if 1 mole is combusted. Then we can divide it by 0.55 gram, and that's the ratio to 1 mole. Then we can multiply it by 15.2 kilojoule. So that's how we get if 1 mole of this compound is combusted, the energy. So the result is 1661 kilojoules. But we have to save to the significant digit, which is 2 digits. Through like in the table, the least significant digit is 2 digits. So we have to convert it to save it to 2 significant digits. So it's 1.7 multiplied by 10 to the third power kilojoules. So the last question, C. A second student performs the experiment using the same mass of water at the same initial temperature. However, a student uses an alcohol burner containing this that is contaminated with water, which is mixed with that. The difference in mass is the same. Would the final temperature of water in the breaker heated by the alcohol burner in this experiment be greater, less than, or equal to the final temperature of the water in the breaker in the first student experiment? Justify your answer. So, first of all, the answer is less than. The second student will have a less final temperature than the first student, because it says the second student's alcohol is contaminated with water. So even though they have the same mass of that combusted, the second one is combusted with water, so it actually has less concentration, or it has less alcohol in it actually. So we can say the actual mass of that combusted by second student will be less than 0.55 gram. Thus less energy released comparing to the first student, therefore less temperature. So that's it for this question. So in conclusion, in thermodynamics, we really have to be careful with a lot of stuff, such as temperature unit. We have Celsius and Kelvin, and also there's a lot of different status that we can describe the process, like enthalpy, heat, energy, and we have to be careful with those units, those different quantities. And also, the most important thing in thermodynamics, I think, is the change, because we're always trying to find the change during the process in the chemical reactions. So that's it. Thank you.